and transmitting. Like in this session also, the information is being collected at the Google server. It's being processed. What do I mean by that? Let me just show you an example. If I click on this toggle CC, this will give you the caption, right? So how is it okay? Let's start this again. So my voice is being sent to the Google server. Where it's collecting my voice data, then it's processing it, and then it's sending it back to you guys so that you can see it. Okay, there's some issue with it, I think. Anyway, and while it's being transported in all these various phases, so where when the information is being collected, when the information is being processed, and when the information is being retransmitted, during all those phases, you have to implement security. You have to ensure security because let's say in the collection phase there's some problems, like if I'm talking and someone someone, and this data is being sent to the server, so it's transmitting to the server, and the server will be collecting it. During the transmission, if someone hijacks my session and deletes some words or deletes some files audio portions, then the data will be corrupted, right? Then during the processing phase, maybe I have injected some wrong data. I have sent some wrong data, and that should be treated at the processing phase. So that's also security implementation. For example, if my token is expired, like if you are exploring, say, Instagram, and your token is expired, when you log in, a session token is created for you, and that is valid for a few hours. Well, Instagram and Facebook, this Meta, usually they give you 1 day of uh, token, and every time you visit their site, they refresh that token with 1 more day. So they don't expire that easily. But let's take an hypothetical situation where Instagram has provided you with a 2 hour session. So you can interact with your friends over, and you can message them, you can follow accounts, you can post your pictures, you can comment, and all. Every time you're doing this, that session token is being used to verify that it's you or not. Okay, so that's an unique identifier that the server remembers that yes, you have been authenticated and authorized to perform certain actions. So authentication means you are allowed to enter the website, so that's logging in. And authorization is the permissions that you have, the level of access you have to the system. For example, if I am a regular user, I won't be able to delete someone else's post. I may be able to like them, I may be able to comment on them, but I won't be able to delete it. But an admin of Instagram will have access to delete certain posts as well. So that's authorization, the level. Okay. So what is a computer? Computer is a high-speed graphical purpose digital electronic stored program data processor, basically an electronic machine that can provide you with high speed calculations, provide you with general purpose softwares, like you want to write something, you have Excel, Word, PowerPoint, these type of tools available at your disposal. Stored program means, let's say if I click on this Telegram, then this is a stored program. If I click on it, it will launch something, right? That's an executable that it will launch. Data processor. So at every instant, our computer is processing some data. Even the slightest cursor movement is also being calculated by my GPU or my CPU, and it's being reflected to my monitor. So that's processing some data. It's processing the coordinates of my mouse pointer and correlating it with where it should be available. It should be visible on the screen. I could be using my mouse in the floor, right? I can be using it on myself or I can be using it on the wall, but it's still able to determine where the cursor should be pointed. These are some basic characteristics of computer. You get speed, you get accuracy, you get storage and retrieval, uh, fast storage and retrieval properties. So I have some data. I can easily search it from here, and I will be able to retrieve that data. Even though if you look at this, my computer is almost full. Is only 6 GB is free. So almost for 69 GB of data is residing in this computer. And if I want to search for something, I can just simply come here and search for it, and it will provide me with that data. Repeated processing capabilities. So if you want to process some data multiple times, that it can also do. If I this tab that I'm opening, this is repeated task, right? So it's able to perform that easily. Reliable, flexible, and intelligence. This is how a computer system looks like. You have input gets processed, then you have a output. This is a more generalized way, a very abstract picture. What do you understand by abstraction? Suppose I say abstraction is basically hiding information or hiding information that is not needed for achieving a task for the user. For example, if you want to switch on your fan, you just click on the button, right? Your fan, or you increase the speed of the regulator. You turn the regulator and the fan speed increases. Now you are not required to understand how the fan actually functions. Like you don't have to understand the what type of motor is being used inside it, what is what is the capacitance of that fan. You're not required to understand how the logic behind how you click on a button and the fan starts, how the electrons are flowing, what type of wire is being used. So that's abstraction. You are those type of data has been hidden from you behind the wall, right? The wires are running behind the wall. So this the first portion. This one, the input processing and output. This is a basic abstracted way. But if you look at it, everything goes through the control unit or in the CPU. In the CPU, you have control central processing unit. Inside CPU, you have two more units. The first is the control unit, and the second is the arithmetic and logic unit. The control unit, and there's also something called a storage bucket. So there will be registers here, and then there will be buses that's carrying the data from control unit to ALU and to the registers. Register is basically the CPU memory. Okay, so control unit, when you input something, the data is being sent to the control unit, or it will be sent to the storage, and then the control unit will fetch data from the storage unit, which is called the buffer. So when you are typing, it's being stored in the buffer. For example, if I open my notepad, as you can see, it says that it's untitled. So it has not been saved yet. So it's in the RAM, right? Everything I write here will be saved to the in the RAM, in a temporary storage, which is called the buffer. And once I click on save, then it will ask me where I want to save this file. Okay. So this storage, the control unit will again decide where I should be storing it to the inside the system, in my SSD, in my HDD, or some other storage unit, or in my pen drive. What is the output unit? As you can see, when I'm typing something, when I type H, the input goes from my keyboard to the control unit, to the central processing unit, CPU, and the CPU will then send it to the GPU, and the GPU will draw H on my screen at this location, at this instance, inside this application. So this is the drawing part, which is handled. This is also output, right? All of this you are able to see on your monitor. So monitor is an output device. It's not an input device, right? Unless you have a touchpad monitor, then that will be an input device. But as of now, this is a output device. So output device is also taking some information. Where is it getting that information from? It's getting that information from GPU, that hey, the GPU is drawing this whole thing again and again. Arithmetic and logic unit is the portion that will handle your arithmetics, which is your mathematical operations, addition, subtraction, XOR, uh, XOR, and operations, these type of things. Left shift, right shift, and logic unit. Logic means verifying, comparing two values. That's logical work, right? What else? Let's see. Classification of computers. Well, computers are also classified based on their according to their purpose, where they are being used, then according to the technology used, what type of technology that you're using inside that computer, whether it's a quantum computer, supercomputer, what type of computer it is, according to its size and capacity, how much it can handle. So, according to your purpose, you have a general purpose computer, like a simple laptop. That's your general purpose computer. You have special computers, which are basically these things, these desktops, but they are more aligned to, say, scientific applications for research, space applications, weather forecasting.
किसने रिमूव कर दिया भाई?
Yeah, sorry about that. Okay, so we were discussing the classification of computers. So we have according to the purpose. You have general purpose computers, the things that we use in our day-to-day life, right? Uh, your laptop, your computer, you are using it for gaming purposes, you are using it for editing purposes, various purposes. And then you have something called a special purpose computer, which are designed to run only one type of application. So if you take your laptop and you donate it to a science facility, then they will use that laptop for, say, a particular set of software. So will they will get rid of all the various other applications, and they will dedicate it to that only single program. For example, if you have Astrometrica, this is computer, sorry, app software which is used for uh, uh, analyzing data of asteroids. So this is a specialized software, right? So you can use that. That's also based on the purpose. Then you have based on the technology that is being used. So I have hybrid computers. Okay, wait a minute. Uh, um, it's been some time since I launched this application, so it's updating its database. Yeah, so here you can open load images from the sources. Let's check if I have something. I think I've deleted most of the data, so it's anyway. So you have analog computers. Analog computers are computers which use mechanics to work. So, for example, your compass. Compass is a analog computer, right? Measures physical quantities like pressure, temperature, length. They work on these things. So, for example, if you take the example of a compass, compass is aligning itself with the magnetic. uh, force of the earth to determine the north and south, right? So that's physical quantity. So if you have if you take the example of a tarazu, the scale weight scale. We now have digital scales as well, but if you think about back in the days, we used to have what do you say, the tarazus, right? They were they if you load some uh, weights onto it, it will tell you exactly how much weight it is. So that's it's depending on pressure. So that type of thing. A thermometer, that's determining your temperature. So these are analog computers. Digital computers will use binary digits, or basically they will use zeros and ones, electric pulses, on and off. Hybrid computer. This is a incorporating in sorry incorporating both these analog and digital into one thing. They store, process analog signals which have been converted into discrete numbers using analog to digital converters. An example of hybrid computers would be your modem, because modem's duty is to change digital signals to uh, analog signals so that it can be carried over the wires, and then once it reaches the other side, that modem's duty will be to convert the analog signals to digital signals. So that's a type of hybrid computer. According to size and capacity, you have supercomputer. Supercomputers are those which have huge number of chips available to them at their disposal. Sorry, uh, they are huge general purpose computers having a processing capacity of 10,000 millions instruction per second. So they can perform this much instructions in a second. Whereas a normal general purpose computer won't be able to do this thing, right? We are limited. But supercomputer is just basically a general purpose computer on steroids, right? And it will also have a storage capacity in billions of bytes. For example, we nowadays buy what I have, what 512 GBs of storage, only 6 GB is left. So this is for me. I have 6 GBs of left for like the last 1 year, and it's still there, right? So we don't need that much storage, and that's fine. But supercomputers are used in your weather forecasting, and they are dealing with huge chunks of data. If you think about this, there's millions of instructions. So where is this millions lines of instructions being stored? The millions of lines of instructions are stored in some kind of a text editor, right? Maybe it could be a C file, it could be a Python script, anything. But that is taking some data space, as well as it's storing data. It's storing the logs. It's getting information from various APIs. It's storing that data inside itself to generate reports and whatnot. So they will have a huge storage capacity as well. Then you have mainframe computers, which you will usually find uh, at a company, right? These are generally fast computer designed for processing huge amount of data. So in what do you call that? Those uh, uh, data centers. Data centers are where you will find the mainframe computers, right? You can take the example of ChatGPT. So the ChatGPT servers, the nest that they have created, that's an example of mainframe computer, because they are dealing with huge amount of data, right? Billions of people are querying their query on ChatGPT, so it's processing that huge amount of data. Then you have mini computers. The mini computers is your phone, your terminals, small terminals, like a normal headless server at a company. Small versions of mainframe computers, like they have at terminals connected with one CPU, and can support many devices. So even if you can take the example of your modem as well again in this scenario. So if you have a Wi-Fi modem at your service, that thing also has a CPU. That thing has a CPU, and it's providing connection or technology to connect to the internet for your various devices, right? So that's a mini computer. Or you can also take your exam. I think personal computer it will fall under, but anyway, mini computer can. Uh, uh, um, Mini computers will also incorporate your mobile devices. Then we have microcomputers. Uh, an example of microcomputer would be your uh, earphones, earbuds, right? That's confining technology in a very small size portion. Or even if you take nanotechnology, that's also a part of microcomputers. Applications and areas of computer. It represents data, binary system. Okay, why the binary system? Okay, anyway, data representation. Data is represented in computer in the format of binary. What is binary? Binary means is a number system consisting of only two digits, 0 and 1. Why two digits? Because digital computers are only able to understand on and off signals. So whether something is on, whether electricity can pass through it, that will be represented with 1, and whether electricity cannot pass through it, that will be represented with 0. So if electricity 1, no electricity 0. That's why we use the binary system in computer. Memory and data storage, and you have secondary storage. These you can just read over on your own. And while we are reading all of this, what's the purpose of information security in this? See, we are storing some kind of data in these computers, right? Be it some mainframe computers or mini computers, even microcomputers. Your earphones are also consisting a set of instructions that it runs every time you are enabling your Bluetooth. So the Bluetooth is always enabled on your earbuds. Once you take it out of your case, the Bluetooth is enabled. So how is it receiving that data? The data is being transferred to it somehow, right? And that's what we have to secure. Otherwise, anyone will be able to hear what you are hearing on your earbuds if they match your right, if they match the right frequency, if they can get your earphone to pair with another device. What is virtual storage? We have physical storage, that is you have, or secondary storage, which you have your hard disks, SSDs, RAMs, and whatnot. In virtual storage, you have your, this is basically used in for extending your RAM. If anyone is using your, is interested in the tech of new mobile phones, you have seen that they usually advertise it like 8 GB RAM plus 8 GB virtual RAM. So that virtual part is that it's not using your RAM. RAM is a very high end device, right? RAM is a high end, is it, RAM, random access memory, is very fast. That's why, and it's very costly also. Whereas if you think about secondary storage devices, for example, an HDD, I can buy an HDD of 1 TB at under 1,000 rupees, right? I can easily get that 1 TB of storage I can buy. But with the same amount of money, 1,000 rupees, I cannot buy a 1 TB RAM, right? Even a 4 GB RAM will cost me 2,000 rupees. Why is that? Because the quality of silicons improve as you go up the hierarchy. So at the top, you have, this is kind of a pyramid. Here you have secondary storage devices, SSD and HDDs. Under above that, you have RAM. Above that you have cache memory, and at the top you have something called the registers, which I have told you that it resides on the CPU, right? The CPU and the registers are on top of it. Same with the control unit will be here somewhere. The arithmetic and logic unit will be here. Then cache will be between this cache. This is your RAM, and then you have your SSD, right? So when the CPU needs some data, it will try to get it from its registers. If it's not there, it will ask the cache. If the cache doesn't have it, it will ask the RAM. And if the RAM doesn't have it, it will ask the storage. Then the storage will reply. RAM will carry it over here, some of data, and then it will send it to the cache again and then to the RAM. Cache will store the frequent data that is being used frequently. For example, you can take the example of CPU as uh, a teacher checking papers. So the CPU is at the CPU is here, right? You have the table, and then you have some. I have someone some assistant, and in there here I have a storage, right? This is my godown where all the papers are stored. So I will ask. I will look at. I want to check papers, right? So I will look at my table. Okay, in my table I don't have anything. So I will ask my assistant, hey, can you get me some? Do you have some papers for me to check? He will say, oh, I don't have it. Let me fetch it for you. So I will go here, fetch some data. Now this person cannot carry over all of this at one go, right? So they will only take one chunk of it, one portion of it, come back and provide you with that, right? So you have various papers, and you also have a grading paper. This grading paper was also residing here somewhere. Okay, they have provided you with the grading paper and the answer sheets. So what you are going to do is you are going to check the answer sheet, and then you will give the marks next to their names in this sheet. So you have various names and marks, blank columns on this paper. Now when you're checking it, once you have done checking, you will not keep it on your desk. You will send it back to the RAM, and the RAM will save it to this portion. So this thing has been deleted from you. Next time you are again asking, hey, give me the next paper. So you will again go back, again fetch both of these data, this data and this data as well, right? And then again give you the paper and the grading paper, answer sheet and the grading sheet. So we can see that this data, the grading paper is being fetched frequently. So what the computer can do is it will store it in its cache, and my table is my cache. Okay, so I will store this thing on the table, and if you look at it, my hand is a register. So I cannot handle a load of data. I can only my RAM is bringing 10 sheets. Here I have 100, and the RAM has brought me 10 papers, but I cannot check the 10 papers at once. I have to check them one by one, right? So I will take one sheet, I will check it, grade it here, and then return it and take the next paper, and so on. This is how a CPU will work. So CPU is this person who's doing all the processing, and then my hands are the registers. This table is my cache, where I have some data that I frequently mostly. For example, there could be a pen as well, right? Black and red pen, black pen, red pen, blue pen, whatever. I use red pen frequently, so I will store it in this storage area. This is my RAM, the person who is fetching me data, and this is my secondary storage or my external storage cell, okay, where my actual data is residing. And you can see the RAM will only store the data temporarily, because uh, it makes no sense for this person to carry this 10 sheets of data or 100 sheets of data at all times, because this person will be doing something else as well, right? For example, this is you are checking the CS copies. Next, the CPU is telling the RAM to fetch copies for information security. and that's a different go down. So the person will go there and fetch the data from there. So it doesn't make sense for me to keep this data. So this person is a temporary storage whose basic idea is to fetch data and provide it to the RAM. And the RAM will also remember where it got the CS data and where it got the IS data, as computer science and information technology science. And the virtual storage, what is the virtual storage now? Now your RAM has a particular area, a particular size, sorry. So it can only cover that much portion. So if it has 4 GB of storage, then it will be only able to handle 4 GB of data. Afterwards, it will your system will crash if you try to load it more, right? So what virtual storage does is it takes some part of the secondary storage and makes it reserve or reserves it for RAM use. So in that portion of the secondary storage, you have created a temporary RAM of sorts. For example, it could be like this: your RAM, instead of going inside the storage and looking for the things itself, it will just ask the guard there, right? Hey, can you find me this data? This can you bring me 10 papers? So that person will bring the 10 papers. Okay. Or you can think of it like assistant of your assistant, the virtual storage. And that storage is more slow. Why? Because that person doesn't have the same experience, you can say in that terms. Because you're taking it out of that chunk of the HDD, right? Or SSD. SSD or HDD both are still slower than your RAM. So RAM will always be faster. And another thing that is faster than RAM is cache memory. And similarly, their storage is also limited. If you go right now search for some laptops, you will see that they have labeled it as L1, L2, L3 cache. L1 cache of 10 MB, L2 cache of 2 MBs, L3 cache of 1 MB or something like that. Okay, so from HDD, at HDD, at the price of 2000 rupees, you can buy TBs of data. At the price of 2000 for RAM, you can only buy, say, 4 GB of RAM. When you are coming to cache, that will only get you 1 MB of RAM, of memory, 1 MB or even less than that. And after that, when you are coming to CPU, it's even more. It's just bits. Registers are bits. Now, why are we understanding the structure of this? What's the purpose of understanding the computer architecture? Because it's crucial to understand how a computer performs certain interactions. How does the CPU compute? Everything is stored in the memory. Everything is there in the memory, and it's fetching the data from the RAM or cache to process it. Now, a hacker's goal is to hijack that memory space that the CPU will always process. For example, if I have my network manager right now running, if I go to task managers, I will see hundreds of tasks that are being running, right? AMD external service. So a hacker can inject some code inside this process, and the CPU will execute those, right? So that's what I want to avoid. You have to understand how this whole thing works. Then you have computer software. What is a software? You have various, basically a set of instruction, is a sequence of instruction written in a language understood by the computer. What is the language that is understood by the computer? Binary language. Now we cannot write in binary language, so we adapted to assembly language. Assembly language is also hard for us to understand. So then we move to some higher level language. So basically we are building abstraction. Then we move to some higher level language like C, C++, Python, these. And now we have NLP, natural language processing. Where, for example, if I say, okay, Google, set an alarm for 5 p.m. I'm not programming that thing inside it, right? I'm not programming it in. I'm just asking the software to do this task. So it's also going to follow that same thing. I am also giving it the instruction and it's following through. So that's what it is, a sequence of instruction. Now, what are the various classification of software? You have system software. What are system software? Utility software or things that come pre-packaged with your what do you say operating system. So in my case, I have a Windows computer, so I will have let's go to system 32 and let's see notepad. Here you have notepad exe. If I click on it, you will see that notepad is executed. So these are various it will contain various link library files, executable files that comes pre-packaged with your operating system. Then you have application software. Application software are those which you download. For example, this thing, Chrome browser. This is an application software. This Mozilla Firefox is an application software. This VS Code is an application software. If I go here, Discord is an application software. Right? These are application softwares. Utility software. These are again your system software that provide you with information about your system. Information about your system like disk fragmentation, disk utility, cleanup processes. These are your utility software. I've already told you the programming languages are, you have machine language, which is binary language, which is 0 and 1. Now 0 and 1 is difficult for us to understand as humans, and it's very prone to errors as well. Why? Because let's say uh, this particular set of instruction will carry out some addition of 5 and 5 or 6. Okay, let's say that this instruction, this whole thing, this sequence of zeros and ones is an instruction that will carry out the addition of 5 and 6. So you'll have some opcode and then followed by some operands. Okay, opcode is what type of operation you're doing, and operand are what are the things that you're doing the operations on. For example, if I have 5 plus 6, then 5 and 6 are my operands, and plus is the opcode or operand. Sorry, operator. Now, in this set of instructions, let's say that this data is being changed to 1 mistakenly. Okay, this thing has been changed from 0 to 1. Now, this could mean that this becomes multiplication. Now, that's not what I wanted, right? And to debug this thing, I will have to check again 0 1 1 1 0 0 0. Array, why is it 1? Then I will have to change it to 0. Now, imagine that this is a file that that your senior has told you to examine and check out, find out whether there's an error or not. So I'm finding it like this. Okay, this 0 is misplaced. You change it to 1. Now the system is showing some another type of error. So this thing is difficult to debug, right? So this is not feasible for us. So what we did was we created assembly language. Now you can do this. Now this is saying that you have to add R1 and R2, and you will store the data, store the result in R1. What are R and R1, R2? These are registers. So these are general purpose registers. You have accumulator register, base register, counter register. If you're talking about 8086 processors, but basically you have these general purpose registers: accumulator register, base registers, counter register, and data registers. So this is fairly easy to understand, right? Like what is happening here. Even if you don't know assembly, you can just look at this and you will be able to have an understanding that something related to add operation is going on. So addition is going on probably, and it's performing addition on these two, R1 and R2. These may be some variables, right? So this is still fairly easy to understand. Now, if I give you something like this, Now, if you look at this thing, what is happening here? Now, a normal person, a layman, cannot look at this code and be able to understand what's happening here, right? The first instruction, which is add R1 R2, is fairly easy to understand that some addition operation is going on. But for the other things, like what is happening here, what is CMP, you will have to look it up. This is for comparison. You are comparing R1 and R2, and then if you have something called a JZ to label 1, then JNZ to label 2. This is jump 0, jump not 0. So what are these flags? What is this instruction? These are called mnemonics in assembly language. So jump 0 is when the 0 flag is set, you jump to this label. And JNZ is when the 0 flag is not set, then you jump to this label. And how do we know whether the 0 flag is set or not set? That will depend on the comparison operator. When you are comparing two variables, the 0 flag will always be set if they are equal. So if you have R1 and R2, they are both equal, say 5 5. So 5 is equal to 5. So the 0 flag will be set. Okay. JNZ, when the 0 flag is not going to be set. Or I can have something like this, JC, which is jump carry. The carry flag is set whenever there is a carry generated, or a carry or a borrow is generated. So you can already see that this is getting complicated, right? Instead, if I wrote something like this, now if I look at this thing, what is happening here? If R1 is less than R2, then this happens, else this happens. Now any person can look at this instruction or set of instruction, and they will be easily able to understand what's happening here. Whereas this was harder to understand, right? So this is basically building your abstraction level. So this is easier to understand. So that's what happening here as well. You have machine language, then you have assembly language, then we came up with high level language like C, C++. Then you have fourth generation, which is basically used to uh, what is this thing? Tend to be non-procedural or less procedural. Sorry. The fourth languages is basically talking about asynchronous programming. So maybe some lines of code you want to start first, then you will get to them later on, and those type of things. Asynchronous programming. Fifth generation is the NLP, which I talked about, natural language. So you don't have to provide it with information. Yeah. Now here you can see the first you have to write down the source code. The source code gets compiled into a executable code, and then that executable code is run by the machine. What is that executable code? That exe file, executables. So your source code, if I write a C program here and then I compile it with GCC, then it will be compiled to a executable file, which is basically a binary file, which my computer can understand. So if you are writing something in C language, then you will need a compiler to compile it into a uh, executable. How is that executable formed? You have to go through the object code, and then the assembler will assemble into executable file. So your C language code or this thing will be converted to this thing by an by the compiler, and then the assembler will convert this thing to this line of code. So the job of the assembler is to convert assembly code to binary code. Job of the compiler is to convert the high level language code to assembly. Okay. And this is an interpretation. What is interpretation? See, there are two types of languages, computer languages. First is a compiled language, and the second is an interpreted language. compiled languages are C, C++, Java, and interpreted codes are your Python, PHP, JavaScript. These are your interpreted language. So in a compiled language, the code is only created into an executable, or it will be run by the machine only if there are no errors present in that source code. So for example, if I have not provided a semicolon here, then my code will not be converted into an executable. Whereas if we are talking about interpreted languages will run the code line by line. So even if there's an error at this line, suppose there's no semicolon at this line, it will still run this and this, but it will fail at this line. So it won't continue forward, but it will stop here. Whereas a compiled language will look at this whole source code, and it will determine if there are any errors or not, syntax or semantic errors, mainly syntax errors. So it will look at for syntax errors, and it will find that okay, you don't have a semicolon here, so it will give you an error, and it won't compile it into an executable. Whereas a Python or a interpreted language will always run the code line by line. Just to give you an example. Hmm. Okay, so here we have a simple C code that is basically going to print this hello world statement. What I'm going to do is I'm going to print it again, and this time I'm going to remove this thing, which is the semicolon. This is a syntax error now. Okay, let me show you. If I didn't have that, sorry, this is a comment I have commented out, so compiler won't take this into consideration. So you can see hello world is being printed normally, but if I change it now, there's some error. So let's see whether it will compile, whether hello world will be printed or not. Because if you look at this, the first line is correct, but the second line is wrong, right? So I should see hello world twice. So, or maybe let's just say it's hello world 2. Yeah, you can see that compilation was failed. Okay, why? Because there's a missing expected semicolon. So you didn't provide a semicolon here. That's why it gave you an error, and it didn't even print the first one. Now let's change it to, let's see, we have Python. Yeah, Python. Uh, let's see what happens here. You can see hello world is being printed, and the second line was commented out. So let's uncomment it, and let's do some wrong things. For example, this is called indentation, and Python will consider it to be wrong. Let's see if it does that. Yeah, unexpected indentation, file name. Okay, why didn't it return the first one? Okay, let me do something else. Or maybe it's Python 3, right? Maybe I should do something else. Python 3 did fix that issue. Let's see. Okay, let's see. Okay, you can see that. Okay, wait. Okay, maybe it's fixing the indentation in itself. But usually that used to be a problem with Python. Anyway, let's say I get rid of this line. Okay, there's no closing bracket here. It should be able to print. Okay, maybe Python fixed that issue. Mm, JavaScript. Okay, so you can see hello was filtered, but next line I'm printing a variable called a. As you can see, the a has not been declared, so I should get an reference error. But before that, you can see that hello was printed, and then I got the reference error. Right? Yes, a is not defined. So my code was still compiled. Sorry, it was still run. This line was run, and then at this line, when it was trying to run this one, it got that this error, and it panicked. So that's the basic difference between that. And then you have operating system. You have your user applications, or this thing. This will interact with my operating system. For example, my browser is being run, is being monitored by my operating system. Right. The operating system is running some schedulers. It's maintaining the file system. It also maintaining the device drivers. So this mouse movement, it's checking whether my all the devices are connected or properly or not. Okay, it's checking the file system, so saving something, and that type of thing. What is a scheduler? Resource manager. So it's constantly checking for your resources. It's reassigning them. You have your network resource as well, so it's also schedule checking that whether the connection is there or not. Right? And then this thing will be interacting with your hardware. Or before that, you have a HLA, sorry, HAL, which is hardware abstraction layer, which sits top of this. But anyway, this is an abstracted version, so you have computer hardware directly. So the operating system will interact with your computer hardware. What is my computer hardware? My monitor, my storage devices, my Ethernet cable, my Ethernet card, NIC, right? My keyboards. Those are my hardware, and my operating system is interacting with this. I don't have to, as a user. I'm not required to understand how I'm going to compute with this hardware, how I'm going to store files physically on the hard disk. So it's performing memory management, so RAM work, file management, the storage work, process management, which process should be running. You will see that your CPU has a job. It will run processes. So there are multiple processes that is running. Even this class that is being recorded, or you can see that this class is being recorded. So that's also a process. I'm talking on this system. You are able to hear my voice, as well as I can switch to these other tabs, and you are still able to hear my voice, as well as you can see the content that is being displayed to you. So all of this is being done by my CPU, right? All of this data is being sent by my CPU to the network devices, to the network interface card, and it's being sent to the Google servers, and then the Google servers is sending it back to you. And that's how is the managing the processes. As you can see, I have various tabs open. I have a network. I have a notepad as well open. So this is another process. Right? I can close this process. I can come to my task manager, and you'll see that there are various tasks. These are background processes. See, I have only opened two tasks. Well, if you look at it, this is also Google Chrome. This is also Google Chrome. So there's Google Chrome here, and then you have a task manager because I just opened this one, right? And in the background, 134 processes are also running. So you can see that there's also something called a Adobe update service. So this service is constantly checking for updates, right, to Adobe softwares installed. Chrome is also running in the background. So maybe I have some applications. I think I have Discord or something. Yeah, I think Mega also uses Chromium. So these are also running in the background. So these things. There. Device management. Well, if you go to your properties, device management, you will see your device management. You will see that you have various devices connected to your computer. Device manager. As you can see, I have an ADB shell as well, so that I can access my computer phone's root access. I can take root access of my computer. Sorry, of my phone. I have audio inputs and outputs. I have a headphone. I have a microphone attached to this headphone. Then and also I have some microphone and headphones that came with this computer, right? With this computer, with this laptop. So those things, the speaker, VLTK. Then you have the battery. This is also a device, right? So you have an AC adapter, whether I have it attached or not. So I have it attached. You can see that is big charging. So I think you have Bluetooth devices. So you have a Bluetooth component inside this computer so that I can enable Bluetooth. Then I have my front camera, the VGA camera, various computer. There's only one desktop. Uh, this one, this driver, this driver. I have only one SSD. You can see that, right? I have no partitions. I have only one device. So that this is this one. Its name is this one. Then I have a display. I am only using this monitor. So if I had attached another one, I had attached another one using the HDMI, then it will be shown on that. There will be another display under this. The firmware human interface devices. Okay, HID. The Then you have keyboard. Why is it showing two keyboards? Because one is the HID keyboard, which comes with the which is mine. I have attached this one, and the standard one, which is my computer, which is my laptop's keyboard. So I have an external keyboard attached to it. That's why it's showing up. If I remove it, it reloaded, and you see that the HID was removed. Right? HID is no longer there. Now let me connect it again. That is- hmm, Yeah. See, HID is back up. Then you have a mouse. I have two mouses. Right? This is my external mouse. This is the trackpad. I have only this monitor attached, so it's showing up this. And in the network adapters, I have various ones. I used some way virtual box also. I created these adapters, so they are here also. I have a VPN adapter for my open VPN connecting to my remote sources. So these are your device management. This also comes under your operating system will provide you with these things. Then comes various types of operating system. You have single program operating system. So a program OS that is dedicated to running only one program at a time. So this will be a specialized computer, right? A special general purpose computer. This can be used in some research labs, or you can just look at your fridge as well. If you have a fridge which has a what do you say that smart controls, that's also a single program operating system. That's also running something, na? It's also when I click on this, it will change the cooling temperature and all that. So that thing. Multi-programming. Multi-programming is executing multiple programs. You have to using the same computer. You want to run two programs at once or compile two programs at once. You will take a multi-programming computer or a multi-programming operating system. Now look at this. This is an operating system. So this is basically an software, right? A software that will govern your computer, your hardware devices. So a multi-programming operating system will deal with only how to run multiple programs at once. Okay, that's its main job. Whereas a multitasking operating system will focus on running various tasks by one user, by a user or a computer system. What does that mean? That okay, programming and tasking might be there some confusion. Programming could mean to compiling, okay, or making codes, multiple programs. Task is running those programs, okay, or you are providing some task to the computer. A batch processing, you have provided it with to check for network connections, send save files after 10 minutes, 20 minutes, take a backup every 24 hours. Those are tasks, okay, and those tasks are programs that have been written somewhere, right? And this operating system will be running those tasks. Multi-user is one computer can have multiple users. So as you can see, I only have one user in this computer, but we can have multiple users here as well. I can search for create user. I I'll have to go to control panel. User accounts. See, I can go to user accounts, and then I can manage another account. So I can add a new user. So I can click on this, and then I will be redirect to this, and I can add more users. Multiprocessing is process is this thing. Browser is a process. Your softwares are processes. So this is a process. This Mozilla will be a process. This Notepad is a process. So multiprocessing system, operating system is example is Windows, which will be able to handle multiple programs. It will be able to run multiple programs at once. Then you have virtual storage operating system. Main focus will be on providing maintaining virtual storage. For example, in cloud computing, this is very important. You will have a system that will be handling your RAM, right? Everyone wants 16 GBs of RAM. Now they are not inserting 16 GBs of RAM, right? They have some high class SSDs, and they are just using partitioned into virtual storages, and that thing is being provided to you. Virtual machine operating system. You have a operating system that is hosting multiple operating systems. Distributed operating system. You have a operating system which has one resource from another computer, another resource from another computer, and it will feel like that everything is working at once. Everything is working on a single computer, but it has been distributed. So again, cloud computing is an example. All these three will fall under cloud computing. Again, network operating system. You're maintaining your network resources. That job will be done by this operating system. So there are various operating systems that are used by users. MS-DOS almost gone. PC-DOS also gone. OS2, Windows NT, Unix. Unix is your this system was is used by Apple. Windows 3, okay, again gone. 95 gone. 98 NT. Windows 2000 server still running. NT is also running some in some places. Linux, an open source operating system. Then you have Java operating system. If you remember those keypad phones, they used to have Java operating systems. Those interfaces were created using Java. Then you have computer networks. So, what is a computer network? You have one computer, attach it with another one. They are now in sharing information. That's a network. Now add five more computers to it. Another network you have created. Now you have given people access from outside the world to your computer network, right? You have a set of, you have to say you have some files. You have downloaded some movies and you have stored it into your computer. Now you want your friends to be able to access that thing. How can you do that? The one example is you can turn up your hotspot, and then they will be connected to your computer, and then you can share that file. Or you can tell your friends to come to their home. They will connect to your wi-fi, and then you can share that file over the wi-fi to the, you can make the folder shareable, and then they can download it easily, right? So that's another example. That's also sharing. That's computer network. We are maintaining a, we are creating bonds in such a way so that we can communicate with each other. And even this is an example of a computer network, right? All of you are able to hear my voice. Why you are able to hear my voice? Because this computer, my computer, is connected to the Google's server. This thing, if you look at this, the meet.google.com. Google.com is the domain and meet is the subdomain. So that is being hosted in some other computer. And this thing, the INDUS, this is my unique ID. I provide this ID to this server, and this server is able to connect me with you guys. You guys are also connected to this room, so all of you are able to hear my voice. So the server at Google is relaying that, relaying this information to you, to all of you. So that's data communication. Then you have network topology. Okay, before diving into computer networks, I have to just I want to clear a doubt that or a problem that you might have not addressed so far. Can anyone tell me what do you understand by data? The Not, I'm talking about the internet data that we usually see that your data pack is expiring, recharge it, top up it. Why do we do that? How does the internet work? What is that internet that when we turn on our internet, we recharge for it? What is that 2 GB recharge? What does that mean? Anyone? Okay, see. Um, I told you that I have a computer, and inside that I have a movie of 1 GB. Okay. Now I want to share this with my brother. I have it on this computer. One solution is I plug in my USB stick, copy the movie to that, and then send it, give it to him. Another one is if I am already under the same network, he's also under the same Wi-Fi, I'm also under the same Wi-Fi. Then why can I just share that file, share it to him? So how can he access my computer? I will open a files FTP port on this computer that will be sharing that thing, and whenever he goes to that URL, that is my IP address followed by the port number. Say I have assigned 8,000 to it, so followed by the port number, and then they will be able to download that file from there. Now this downloading portion, even when you are opening Google Chrome or anything, if sorry, if you are opening up, let's say this thing, this is an HTML page. This all of this is an HTML page, right? And you can see that it was sent to Google. Google said that okay, this is Facebook that you are searching for, and then it returned me with this HTML file. If I go to inspect and go to network, let me clear all this and then refresh it. You can see that there's some queries that is being generated. Now here you can see what is this thing. You can see that this is the header, this is the URL that I had, right? And this was some payload. This is my query term, which was Facebook, and this was filled by Chrome itself because it's logged into this account. And then it returned with this response. So what is this? This is an HTML document, right? And returned this thing to me, which can contain some, like this is containing Facebook apps on Google Play. So it will be somewhere here. Yeah, Facebook apps on Google Play. So this whole page is an HTML page, and it responded with this thing. And if I go to uh, where is the, yeah. So I have downloaded some HTML page, right? That's why I was able to say this. It responded with this thing. This is an HTML document. Document is a file. To view a file, I have to download it, right? So if I have to download it, then it will cost me some data, and my ISP is going to deduct that much amount from this. For example, let's say this page is 20 KB, and my data pack is 20 GB or 2 GB. Now my ISP, internet service provider, say Airtel, Geo, whatever they are, they will deduct this 20 MB of data from my data pack. So I have 2 GB of data minus 20 KB, or say let's say 2 MB. Then I will end up with 1000 2046 MB left, right? 2048 you will have, and then subtract 2 from it, 2 MB or 20 MB. That much data will be deducted from you. Then you download something for 1 GB, 1 GB info video you have downloaded. So it will deduct that much data from your packet, from your package. So it's 2 GB minus 1 GB. You are left with 1 GB. So that's how internet works. Okay, that's how this ISPs works. So you're just paying for how much you can download from the internet. So internet basically sharing resources. So you're sharing files, photos, text, various kind of things. Network topology. Topology is how the system is. Akshay, you are unmuted. Can you mute yourself?
Sir, I have one question.
Yeah, yeah, yeah,
Like, you have given the example, like, if we are in same home and I want to share some movie to my brother.
yeah,
So, like, if my internet is down, but both are connected with Wi-Fi. So, can I share? Or if
yeah, yeah.
internet,
No, no, you don't need in. No, see, okay. This is a good example. If you have you guys used Share It?
yeah,
Do you know
yeah.
what is it? Yeah, so Share It. You in Share It, we didn't share file using Bluetooth, right? Because Bluetooth is slow. It's slow, very slow. So hotspot in Share It, there was a condition that you have to enable a hotspot, and your friend will connect to that hotspot, and then the file will be shared, and that was faster. Why was that? Because this is your modem, and this is you, this is your brother, and they are all connected to this network. Okay, you are
Mhm.
also connected to this network. He is also connected to this one. Your IP is A, his IP is say B. Okay, and this IP address is say O. Okay, the network devices also have a, the router will also have a IP address. Now you want to connect to Google. Now Google is not inside your inside your room, right? Google server is not located inside your room. So this server is located on the over the internet at some Google facility. So this router will connect to your ISP, and the ISP will forward it to the Google servers, and it will follow some more along the chain. It will resolve its DNS queries, and then it will send it to the connect to the Google server. The Google server will return the index.html to the ISP, and then this file will be returned to your router, and this will be returned back to you. Now, this doesn't mean that if you have, let's say, you have not paid your bills. So, what's happening here is basically this connection has been broken from your side. The ISP, you can still connect to the ISP, but you cannot connect afterwards. The ISP won't forward your request anymore because you have not paid your bills. But if you look at this, you are still connected over this network. This network is still there. If you want to search files within this thing, then you can still do so. You're not you won't be able to extract data outside of this circle, but you can extract data from inside the circle. So for that, what you can do is, let's say I think I have some movies here. Let's see. Okay, I have martyrs. So I want to share this file, right? What I can do is I can open I will create a simple Python script. Let's just let me demonstrate you. You can simply go to, even Chat GPT can give you this thing, right? If I just go to Chat GPT and I will say that, okay, uh, make, make me visit the please simple HTTP server you are creating, and here you have it. Yeah, it has created with this thing. I will just copy this. Okay, let me just create a file here. Let me just do one thing. You can see that I have, it says that the port number is 8000, so I can change it to 8008, 8010, or something like that. And then it's basically sharing this directory, whatever this source directory it is available on. So it's sharing this particular directory, and inside that directory, I can see I have martyrs.mkv, and it's saying that you can add your own IP address, but I don't want that. Let me just get rid of that. So if anyone wants to access this, they can go to this localhost. Now, localhost is only available to this computer. If my phone, I want to connect to this with my phone. Let me just run this first. Uh, let's see if this runs. Okay, so it's running. If I visit this from my computer, I can easily visit, and let's see. You can see that I have martyrs.mkv, right? The directory listing for this thing, martyrs.mkv. Now, if I want to, my brother is also connected to the same network. Then, if it types localhost is a loopback address. This localhost represents your computer. Okay, so you have to find out your IP address. So let me just open up another CMD. This is my IP configuration. Okay, my computer is running a bit slow. Okay, let me close some files. Uh, uh, okay, so Ethernet adapter, LAN adapter, where is it?
1.13.
There are various files here. Wait a minute. Let me just check. Ethernet virtual NCA, VPN, local area network. This is my IP address. This is my local IP address, right? This is my Ethernet adapter, and this is my Wi-Fi. I think I am also connected to the Wi-Fi network. Let's check. Okay, I'm not connected to the. It's connected. But anyway, this is my Ethernet adapter, so I can search for this IP address. I will open it on my phone. 192, 1.13, 192.68 dot 1.13, and then colon 8000. Yeah. Um, how do I show you guys? Wait a minute. Is okay. Do you see this? This is my phone, and you can see that in the search bar, I am searching for my IP address, which is 192.168.1.13, and I can see these files. So if I click on the martyrs file, it will be downloaded on my system. Let me try it. I've clicked on it. See, I am getting the pop-up to download it.
Okay.
Okay. So this is how you can share this file. And all you have to do is now, suppose I want to share some other file. What I can do is I can come, let me close this. I will come here. Okay, there's some error that has happened, possibly caused by the remote host. I can just give it to ChatGPT, and it will fetch it, fix it again, or I can just search for a script over the Stack Overflow or from Reddit. I can get the proper script. And what I can do is I will just stop this server. Once the service is stopped, this process is no longer running on this port. So if I refresh it, it won't be here. See, it's gone. It's not reachable. So what I can do is I can simply just take the share file. Okay. Let me close this. Yeah, I can just copy it, come here, paste it here, and then again click on it. This will run my service. I will go here. localhost. And now you can see that I can access the martyrs folder, and inside the folder I have these things, right? So if you want to share your whole what do you say, and you can see that it's showing you that this folder was accessed, right? So I can close this, and now I can just cut it, and let's say I post it to my downloads folder. I paste it here. Okay, then I click on this. Now this whole thing is being shared. I refresh this thing. Now look at this. All the files are now available. So anyone can just go to this address within my service and can check out these services, check out these files. So this is how you create your own server.
And while downloading this, we will not lose our data,
No,
like data pack.
no, because you're downloading it from your own system. You're not relying on the internet service provider, right? So no problem.
Thank you.
Welcome. Now you have topology. Topology is how devices are connected. Okay, how devices are connected to each other physically. So you have star topology, in which you have a modem, and from that modem you have computers connected to each other. So this computer is connected to this wire connecting it, the Ethernet cable. This is another Ethernet cable connected to this another. Now this device wants to communicate with this device. This will send a data. Say this IP address is A B C D. So it will say that I am A. I want to send data to B. It will send to the modem, and the modem will send it to this computer, and then this computer will receive it. If it's not a modem, or if it's say it's a hub or a simple hub or switch, then the data will be broadcasted. If it's a hub, so if you send data to this computer, this device, it will broadcast to this device as well as this device. This device will see that the message was intended for it, so it will receive it. But it will, this is the IP address is C, and in the receiver address it will see that it was meant for B, so it will discard that data. And same with this one, this will also discard that data. Now why is this why are we understanding this again? Topology, to understand this, you must have heard this thing that you should not do your banking transactions using a public Wi-Fi. So if you are sitting in a cafe, say in Starbucks, and you are using their Wi-Fi, you're connected to their Wi-Fi, then you should not do any transactional or share in sensitive information when you are in that network. Why? Because it will be broadcasted. As you can see now, this data was meant for this computer and it kept it. The data was not meant for this and this computer, so they discarded it. Now a hacker can do what can they do? Can is simply make their computer accept every day data, because they already got the data. Now is they have to determine whether they want to keep it or discard it. So the hacker may configure it to keep the data. So it will keep the data, and it will also configure that if the data is coming from this machine, then only keep it. So that thing. So that's why you should not use share your sensitive information over the internet, even if it's even if you're using HTTPS, which is an encrypted traffic, because hackers think in the way that you have to store it now, decrypt it later. Store now, decrypt later concept. When the computing system has reached the point where encryption can be decrypted, can be broken, say this, they are just waiting for that thing. So they are storing it for now. They are storing this bulk amount of data, and then they will decrypt it later on when the technology is there. Then you have ring topology. In ring topology, one computer is connected to the another one, then this computer is to the another, and so basically creating a circle. Now, what's the disadvantage of this computer? This thing, this is fairly easy to set up. You will have some restrictions for the amount of wires, because you will have to buy wires for each and every computer. So if you have n computers, then you will have n wires. And there's one downside, that is if the modem, this thing, breaks down, then the whole network is dead. But if one computer is dead, say this B computer is dead, then A can still communicate with B, C, and D. right? Only this computer has been shot down. uh, Unless this until this is one working, the network is working. But in ring network, you can see that computers will, and there's an unidirectional flow. So the information sent by this computer can only be sent to this computer, and then what it can do is, say this is A, B, C. A wants to communicate with C, so these two want to communicate. They don't have a direct link. So what will happen is it will send the message to B, then B will discard it, and the message will go to C, and then C will keep the message. Again, there's a problem. Suppose this computer is dead. Now this computer and cannot communicate. These two computers cannot communicate. Not these two computers. Only this computer can send data to this one, and this to this, because there's an unidirectional flow, right? Only one way. And in ring topology, you also have a concept of token ring, deciding which computer will be sending the data. So whichever system has the token, they will be sending data. So suppose this and token is something, a packet that is being circulated over the network. So if this computer has the token, it will send the data, and then it will release the token. Then the token will flow to this computer. This will take the token and then send the data, and then release the token. Then so on and so on. It will keep on repeating. In bus network, you have a single line, and from those you have small nodes that are dropped to connect to a computer. The disadvantage here is that if this main line is down, then all of it is dead. And again, another one is the cost is also high to set up a bus network. Although there is also the cost will be minimum, because you have only one line that is running, and these computers are just connected to this line. But the downside is, even if one side is broken, even if this side is broken, you will say, okay, this is not connected to this thing. So why would the network shut down? Because electricity. If this thing is broken, the electricity is not flowing. If the electricity is not flowing, then how can these two communicate? How can these communicate? Right? So even a small damage in a bus topology can lead to breakage. But if this wire is broken, then nothing will happen, because the backbone is still alive. A mesh topology is a topology in which every computer is connected to each other. So this is not a exact representation of mesh topology. What would happen is this computer is also connected to this computer to this to this, and so on. And there you can see there is two networks. So this is another one. Tree network. Tree network will have follow a tree-like structure, or if you look at the family tree, right? Family tree structure. So this is a another branch. This is another branch. This is another branch. Suppose this is for financial department, so they have their own network. Then this device, this is say developers department, they have their own network. And this is your HR department, which has their own network. And if this computer wants to communicate with this department, then they will send the data to this router. The router will route it to this computer or to hub, whatever the devices they are using. Local area network. When you set up a network that is within uh, a very small area, say 20 meters, 50 meters, 100 meters, within that range. So a computer lab, or your home setup, that's a local area network. Then you have wide area network. Wide area network is your internet. So this is not a good comparison. After local area network, you will have campus area network. So in universities, you will have a computer network set up at a computer lab in block 1. Then in block 2, you also have a computer network, and these two networks are connected to form the campus area network. So the campus area network will expand more. There's also something called a PAN, which is personal area network, which is your own personal hotspot that you create, and your friends connect to it, right? Wide area network is, and then afterwards it will have, you will have MAN, which is metropolitan area network. So you have LAN limited to your own building. Then you will have MAN limited to your city. Then you will have wide area network covering the whole world. Metropolitan means city, right? So a metropolitan area. So Delhi, this network. So like if you take the example of Delhi Metro, so Delhi Metro is a metropolitan area network. Is a comparison between them. Then you have data transmission mode, how data is sent over the network. You have simplex mode, in which there is only one way communication. So for example, if you take this TV, when you turn on the news channel, there's only one way. You cannot talk to the news channel, right? You are just receiving the data. There's only one way communication, and that too from the sender to receiver, not vice versa. Okay. So your dish TV that is receiving the data, right? That thing. Now you can say that the live matches which you watch on your Hotstar, is that an example of simplex mode? Not exactly. Why? Because while it's live streaming you to Hotstar, you still have the option to go back, right? You can still rewind it if there is rewind option available. You can still rewind it back to 10 minutes, 5 minutes ago, and watch it from there. But simplex mode is, your data is only coming through. What you have done is, you have rewinded it, and you are fetching data from that time stamp onwards. So that's you communicating to the server. That's not possible in simplex mode. So the example of simplex mode is, when you turn on TV, you are watching a serial. So the serial is being sent by the cable providers, and you cannot uh, what you say, you cannot rewind it, right? So that's an example of simplex mode. Then you have half duplex mode. Half duplex is, one way communication is still there, but the sender can talk to the receiver, and the receiver can also talk to the sender, but one at a time. So for example, you have walkie talkie. In walkie talkie, you will press a button, then you will say your message, and it will be received by the another person carrying the walkie talkie. And if they want to talk to you, they will press their button and then talk, uh, relay their message to you. But if you both press your buttons at the same time, then neither of you will hear a message, right? So that's an example of half duplex. Then you have full duplex, which is this thing, whatever we are having right now, right? Whatever we are having right now, this is a full duplex mode, where I'm communicating with you, and you can also communicate back with me. The It doesn't have to be like I'm talking, then you can talk in the middle, and then I will stop, and then I will go to you. But it doesn't. Unlike walkie-talkie, if this was a example of a walkie-talkie, I've pressed the button and I'm continuing to talk. Even if you talk back, I won't be able to listen, right? Unless I stop, unless I release the button. So in full duplex mode, both the party can talk to each other. Analog data transmission is when you are sending data in analog signals. That is, it can vary, the amplitude can vary, the frequency can vary. But in digital data transmission, you only send either 0 or 1. So either the current is going or not. So this is a discrete signal or digital signal. Whereas in a analog, you have continuous data flow. So the data is changing from 0 to 0. 0.5, 0.2, 0. Then going back to minus 0.2, 0.3, so on. So this is continuous and this is discrete. Discrete is solid value. Continuous is decimal values. So it will be either 1 or 0. See, there's a sharp edge. It's falling edge. And then it becomes 0. Then it becomes 1. Then it becomes again 0 for some duration. And then it becomes again 1 for some duration. I've already explained what internet is, but you can just go over this again. A web browser is a software which will be talking to various other initiating the internet connection. Web browser, this will help you connect to other services. So it always sends a get request to other services, and the services that are running over the internet will respond back with their corresponding get request, for example, an index.html file. So even if you type in facebook.com, so that's a request, that's a get request, you are getting the resources, and then the Facebook server will respond back with the login page or sign up page or the your home page if you're already logged in. What is URL? Uniform resource locator. This this is an resource locator. It's used to find resources over the internet. And what does uniform mean? That the structure will be followed strictly. There's a protocol behind it, and you have to follow that protocol. So if you take the example of, they have provided this http www.khoj.com, and another one is http google.com. So http is the protocol, hypertext transfer protocol. This thing says that you are dealing with hypertext. What is hypertext? Hypertext markup language, XML, extensible markup language, these things. You are dealing with HTTP or HTML. Then this is your separator, which will start the actual URL. So this is a protocol, and using this protocol, you are trying to access this URL, this resource. The first thing, which is the www, this signifies the World Wide Web, which is the subset of the which is a border term. Under this www, we have various organizations, or you can say that the Google is part of the www. Or usually we read the URL right from right to left. So we will first read in, so that this will say that this is inside India, and inside the Indian domain you have which is the commercial domain. So inside India, there's a commercial domain belonging to Google, and Google is part of the www. So this is how we are reading it. Net. What is net? Have they provided? No. Anyway, net is a top level domain. Okay, and purpose of the sponsors of the site indicates the purpose. What is this? Oh, com. So you have .net, .com, .edu, .ml, AI, various domains that you are available right now. Com for commercial, edu for educational. There's also under edu, there's also called AC, academic domains, right? So AC. Then you have mil for military, gov for government, org for non-profit organizations. Then you have not .net domains for network providers. And what is international treaties, international databases. There are various domains that are available. This is also not exactly completed. Afterwards, or you can also have some resources. For example, in this, you have this domain. So if you look at it, this is a commercial domain of Google, and inside Google, it's the Meet. So it's running from the Meet domain, and is using the HTTPS protocol. The S stands for the SSL. It's providing you the SSL, the transport layer security, or the encryption. And then you have this resource that inside this domain you are providing it with some parameters. So this is a parameter ID. So you are providing this data to this server, and this server will deal with this and then connect it to the proper source. Intranet is internet is outside. You are out accessing data from outside. Intra is you are accessing data from inside your own network. So if you are sharing files within your network, then that's intranet. Extranet is a private network that uses the internet protocol and the public telecommunication to secure share part of business information or operation. Can be an extension of intranet that makes the later accessible to outside companies with an internet. What does this extranet means? Extranet is used by big companies like Google. So what they have is they have an intranet. So they have a network set up inside their uh, provision. So say Google, in Google Delhi, the Google office of Delhi will have an intranet, and that office is connected to the Google Mumbai through another channel that they have purchased, let's say. So that's a intranet. There's one structure, one network in Delhi, and another network in uh, say Mumbai, and they are connected to each other, not over the intranet. They have also connected to each other using a pipeline system. So that's extranet, and this can further be connected to, let's say, the Google Mumbai is connected to California, Google California, and so on, and that will be used using the internet. So they are using both the intranet concept and the internet concept. Okay, but mainly focusing on the intra part. Computer security, you have three parts. First is the hardware security. You have to physically store your devices in such a place or in such a location or in such a conditions such that it cannot be hacked, right? Like for example, if I have my computer and I set the password to nothing, then anyone can access this computer. So that's not hardware security, right? And if for example, if I take my pen drive and I leave it on the desk, that's where's the hardware security? For example, that maybe that stick contains some sensitive information. I should not be just keeping it here and there, right? And even if I am using a software stick, I can use encryption on it, right? I can, if you have used Kingston pen drives, they use encryption, so you can only open it using passwords. Then you have software security. Software security is, for example, I'm using Google Meet, right? So to use it, I have to connect to my Google account, and to connect to Google account, I have to provide my email and basically my credentials, like my authentication. I have to authenticate myself. If I don't authenticate, I won't be able to connect to you guys. So that's software. Information security is, now Google has my data. I have signed up for this service. Google has that information. They have my email address. They have my name. They have my photo. They have my phone number, my address, everything they have. Whatever they have asked for, I have provided them. So they have that information. Now, if their information is leaked, if that information gets leaked, then Google is to blame, right? So they have to provide some information security on that data. That is, they have to provide encryption of that data. If they're storing password in plain text, then that's a big no-no. You should always store information or sensitive information in encrypted format. So I should not be storing passwords in plain text. I should be storing it into an encrypted, let's say 256 hash state. SHA-256 I can use to encrypt the password. Because even if the database gets leaked, there's only email and then followed by the, or username followed by the encrypted password. Hackers can do anything with it. So that's information security. You have viruses. You have a virus is a computer program or a software, or which is basically going to attach itself to other files and then infect your system. How is it going to infect your system? It can create some backdoors. It can create some CNC network. It can create a uh, it can what you say um, it can also do overload your system, or the virus can be in the form of a ransomware. So it will encrypt all your files and then will ask for your money. In computer viruses, you have various uh, shown here like this. System, yeah, symptoms. How to know if your system is under a virus attack? If your system memory is less, getting less, or if you have used 4 GBs, your RAM is 4 GB, and now it's suddenly always you have 1 GB left or 500 MB left, then your system is being used by some computer, by some other program that is draining your resources. Hanging up of machine and program for no particular reason. So my browser is hanging out of nowhere. I'm getting pop-ups. So that's an example of a virus attack. Delayed disk operation, that is, you're searching for something and it taking forever, or you're saving something and that's also taking forever. So that's an example. How to protect? Use antivirus. Only download software from reputed sources. uh, Testing news applications on standalone system. So instead of connecting your running applications on your company laptop, run them on your what do you say, on a standalone computer that is not connected to any other computer on or connected to a network. Educate, awareness, spread awareness regarding this. How that you are doing, you should not trust emails. Stay away from phishing emails. Don't click on unnecessary links. Don't download unnecessary files. And always don't download cracked software. Always use the always download softwares from the authenticated source, right? Legitimate sources. So that's it. That's your unit 1. And then you have security awareness portion of the cyber security. So just go with this unit 1. If I have some doubt, we will discuss and then we'll move to the next session. Okay. Yeah, so intranet and extranet, right? Give me a second. And guys, can you please put your enrollment number and in the chat box again? I was removed previously, so it got removed. Just put your enrollment number and name in the chat box. Okay. Okay, so intranet and extranet. I have taken this diagram, so this I think shows you. Might give you an example. So intranet is this thing. This your company. Okay. So any the network inside your company is the intranet. Then what you have done is you have provided the functioning of this intranet to some providers. This is your extranet. What is that extranet? That this is you have some services. Okay, you have some APIs, you have some services that you are running, and then you have provided that information. You have created a channel so that this can be used by some other companies as well. Okay, now let's an example you can take is Google. So Google's the database, the internal everything is the intranet. Okay, this is the company which is consisting of an internet. This is forming an intranet. Then what they have done is they are supplying the data that they have stored, the user analytics that they have stored. They are providing this to extranet. How they are providing it? They are providing this information to say some ad agencies. Maybe they are selling it to Amazon. Okay, so they are selling it to Amazon. Amazon is a company, another company, and they are able to access this information which is coming from inside the company of Google. So that's extranet. Okay, now why is this extranet not internet? How what's the difference? The difference is that this network can only be accessed by those who have been authorized by this company, who have been authorized by Google. So Google has created a portal, okay, a portal that can from in which these suppliers, Amazon and other things, can come to this portion and uh, provide their data. Okay, keep their data in here. And then internet is the whole world. The whole world is able to see some portion of Google. So that's the internet that that it can access. Another example that you can take is, see, intranet is their servers, Google servers, and then extranet is your driver, the Google Drive that you have. So you say drive.google.com. So it's inside Google, and Google has provided you the access to its machines, to its hardware through those drivers, right? And you can take extra storage, right? See, Google has provided over the internet everyone the access to 15 GBs of data. They can store 15 GBs of data. And now, if you become a one user, Google One, then you can access more storage. So you are kind of accessing this portion, the extranet portion of it. And maybe Google is providing you with more capabilities. Maybe it's providing you with some APIs also, so that you can save data to this your drive in a more efficient way. Okay, you don't have to always open up drive. You can just call the drive APIs, and you can save data to that, or you can fetch data from there. Does that make
Sir,
sense? Hmm.
P2P is coming in which category?
P2P is a protocol, right? Point to point. So if you have
Yeah.
a computer and you have another computer, they are connected to directly, then that's a point to point network.
So that is intranet.
Yeah, you can. Yeah, you can say that's an intranet. Intranet inside in, see, P2P is an old technology as well. So I'm not sure if I can give you an real world example. But yeah, P2P can be used over the intranet, extranet, as well as the internet. So if you take off extranet in this case, you have Google, they have a server in which they have stored some data, okay, and they have provided a direct access to that computer to these other companies, so that it will have a IP address, say 172.718.2.2, and this IP address, they have not used any domain name on it. They are using the IP address, and they have provided this IP address to this Amazon. Now Amazon can directly access that data. They can just put that thing, their IP address, in the search bar and go to the dashboard and download data from there.
Okay.
So that's also point to point. Okay.
But sir, most of the branches are also connected with the P2P links.
Exact. Yeah, yeah, yeah. That's a good example. Branches are connected with P2P strategies. If you take the example of even the network topologies, in network topologies, you will see that in the tree topology we had uh, the modems were connected to each other, point to point. Where is it? Yeah, you see these two computers are connected to each other. This is a point to point. If this is a computer, then this is point to point, point to point. This is again point to point. But if you look at this particular structure, this thing, this is a point to point network actually. This computer is directly connected to this computer, and this is connected to this one. Okay, and you can see that these networks are also connected to each other in a point to point strategy. Okay.
Okay, sir.
All right, then you have the next unit is on awareness, security awareness. What are the fundamental of security awareness, the life cycle, the awareness session, the material that you have to provide. This is basically how you have to train your employees or your staff on the fundamentals. You have to design some awareness program, material, PPTs, or live demonstration. For the live demonstration principles, you will develop some material as well. Then you will have awareness implementation, that it will be on this particular day, right? And then you will have some activities inside that. For example, for a phishing email awareness, you will have activities like people will check their email and try to find out whether a mail is a phishing email or not. They will just go to their spam emails, and then they can check from there whether that particular mail is a spam or just a false spam also or not. These are various models. You have a centralized model, you have a central authority. The central authority will determine all these programs. Then you will have a partially decentralized model in which you will have every department will be performing their own awareness programs, or they will be combining their efforts in terms of security awareness. For example, accounting division is facing with some particular type of cyber attacks. Uh, the development department is facing with some other set of uh, cyber attacks. Then they will develop their own awareness programs. For example, if you are in the HR department, then your awareness program may be limited to do not click on suspicious links, do not open emails from these domains, or do not open or do not download exe files or executable files from untrusted domains or from emails, these type of things. And same for the development department. The development department's awareness program will revolve around that you have to use JWT tokens for authentications. You have to verify, you have to use refresh tokens, you have to verify every time whether the request is valid or not. These type of things, this is more in the technical field, and this will depend on the complexity of each division, right? For example, accounts will be dealing with some other type of accounting problems, accounting errors that they might be facing. Okay. Then fully decentralized, and see, it's partially decentralized, so it's all these departments will report back to the CIO, okay, the chief information officer, uh, that they have conducted these activities, this they have conducted this, and this was the output. The team is educated on this particular portion of the attacks. You gave us more details on which activity we should perform next, these type of things. And then you have something called a fully decentralized, in which they have their, or the department will carry out their own awareness program without they will be reporting directly to the CEO, or some they will be managing some records in their own department, not necessarily sharing it with the CIO or anything, anyone else. Okay. This is how you can create some programs inside it. So example, decision table for user, detection of suspicious activity problem, high importance, yes or no, and based on that, some situation critical. You have detected something, you have detected something suspicious, and based on that you are determining whether the situation is critical or not. If it's of high importance, if the high importance is yes, and the situation is also critical, then SOS alert through SMS or phone. If it's of high importance but it's not critical, then inform via email. If it's of not high importance, so no, but it's a critical situation, then post advisory instruction. Okay. And then if it's not of high importance, not a critical situation, then just relax. Yeah, nothing is going on, just chill. It's not anything, right? See, you have to understand how this table works. This is the decision table for a user. Okay, now this user can be belonging to some IT department, or to the HR department, or to a financing department. It will depend. And then this is the situation, that what decision you should take if this is the problem that you have faced. Okay, that you have detected some suspicious activity or problem. If this is the problem, then check whether it's a high importance thing, or if the situation is critical or not. Based on that, take some decision. Okay, so you can create these cards and provide it to the your employees. Make awareness sessions, awareness material, gather material from various sources, give them this material will also may be used in the activities, right? You have gathered some suspicious emails, and then you have provided them as an activity to every employee, and they have to determine whether it's a phishing email or not. Based on that, you will give them some praises, prizes, or anything else. Okay, whatever you have to do to keep the morale up, that type of that thing. Regular update on material. For example, if your material is of 10 years old, you are still discussing DOS attacks. DOS attacks are almost gone. There's no DOS attacks going on anymore. Even DDoS is gone because of Cloudflare technologies, right? So they are almost gone. You're still teaching about DDoS. Then what's you have to update your material. You have to update your examples. Okay. Top management communication to staff. So yeah, the management should be communicating with the staff, the employees, regarding critical vulnerabilities that they have found, or critical threat intelligence that they have gathered, to educate their employees further. This is a good poster. See, do you share your toothbrush? Then why do share password? It is very common that if say you have a Netflix account, and your friend says, hey, can you give me I want to watch this movie, do you have an Netflix account? You will say, hi, yeah, have this, this is my email address, this is my password. You have given them that data. Now if you're a layman, and usually or most of the time people use the same password for multiple accounts. So maybe your Gmail account and your Netflix account password are the same. Then why are you sharing this password? Right? In the spur of the moment, you forget about that this password is also belonging to your Gmail account or your Facebook account, and you have provided them with that. Now you know they are trusted. The medium you have shared that password on, how can you trust that media? How can you trust WhatsApp? How can you trust the Facebook communication and Messenger? Right? So this thing. And even if you have shared them to them, the thing are in plain text. We just talked about how you should store sensitive information in encrypted format, and now you are just sharing your email and password in plain text, and the person can, anyone, say your friend has kept their phone open, and someone opens their checks their phone, and they are able to see the password in plain text. They take a photo and then leak it, whatever they can do, right? This make security awareness implicit. What is implicit? There are implicit and there's something called explicit. Explicit is you're forcing it, right? You have to make it implicit. That is automatic. That every time you are doing something, you have to think about the security portion of it as well, right? So that your employees, even though see these sessions, these are explicitly you are performing them. You are explicitly providing these sessions. You are providing these examples. You are describing these modules, these materials to their employees. But if they're not taking the initiative to learn something, right? For example, if you have just talked about social engineering, and the next day someone clicks on a picture of a puppy they have received from a on email, then what was the point? They have to implicitly think. It has to come to them naturally that why on my personal email someone is, or on my professional email someone is sending me photos of dogs, right? That's something they have to think about. And when they're opening their email, they should not just click on something randomly. And even if you want to open something right like that, let me just take you an example. You can use this extension, the square x. I can open a disposable browser. Say I start this one. Now I have received an email. I can just put it in this browser. This is on a different machine. This is not my machine, right? I can just put it here and check whether it's a virus or not. If it's a virus, then I will just close it, delete group, leave. That's it, right? So this type of thing, involve everyone, continuously awareness, refresh courses. Hey, you have to continuously provide them with material, news, updates, and at at a particular point, they will have that ingrained in themselves. If they are continuously seeing this thing that phishing emails look like this, social engineering tricks works like this, then they will be aware. This will be built in. This will gradually built inside them. The implicit part, also security awareness. New performance review orientation. Review what they are, how they are performing on the security task as well. Don't exclude contractors and part timers. See, you are only, if you are only, your sessions are only for your core employees or your permanent employees, then, and you are not including your interns or part timers or your contracts, people who are there in the company based on some contract, right? If you are not including them, then they also have access to your company, right? What if an attacker, they download some virus? They are part of your company still, even if they are part time. They are still part of your network. then why would you exclude them? You have to educate them as well. So that's another point. Mandatory awareness training. Don't make it optional. Mandatory. Make it mandatory. Make it required. Every employee must do this awareness training. They must fill out some questionnaire or something, some Google form or something, and based on that, you can assess whether how much aware they are of cyber attacks. Signed agreements. Signed agreements, like if they release this type of document, this will be this type of punishment will be uh, availed on them, like this, which is already there. Signed documents are always, these are part of your employee contracts, so this is always there, that you should not, after leaving the company, you should not be spreading their data, right? You should not be talking about their internal projects. Right? How to manage them for permanent staff, how you can do this for temporary staff, your part-timers, interns, contract agent, auditors, non-employees, your technical staff, then your security officers, what they have to do. Then some level of awareness programs, security threats, what are viruses, bombs, how to handle these type of things. And then you have uh, uh, password, how to handle password. Do not store them in text format, in do not write them down somewhere, do not keep them in your purse or in your drawer. If you're keeping it in your drawer, lock the drawer, right? These things. Guidelines relating to password, that a password should be of 16 characters. It should contain it should not contain your name. That's one thing. It should not contain your it should contain numbers, special characters, lowercase letters, uppercase letters, numbers, so on. Never share your password. Save your password on your local machine. Don't save it on your local machine, because if your local machine is hacked, then your passwords can be easily extracted. They are sitting there in plain text, right? So there. And yeah, yeah, another. If your browser asks you to whether you want to save a password, say no. See, you have there are pop-ups when you log in to save the password. Just say no, because if someone hijacks your browser cache, then they can easily get those passwords. And always change your password on a regular interval. For example, let's say every month you are changing your password. Every 2 months you are changing your password. These things. How to surf the internet and how to perform online transactions. What type of website you should look for. Why you should look for only HTTPS websites, because they are secure. Why you should not do online transactions in a public network. These things. Do not click on unnecessary links, or do not go to suspicious websites, right? Or even if you are going, like I said, you can use this extension, SquareX. They provide you disposable browser, disposable file viewer as well. You can open a file, you can download the file on this thing and then open it here. So even if I have it on your system, you can open it on this thing, and if it contains a virus, it will be limited to that session, and I can just delete it, so it's gone. Get information on secure website and SSL certificates. Look for the HTTPS, obviously. Make sure your certificates that you have downloaded, the digital certificate and SSL certificates, are valid. Google, the browsers will do it for you most of the time. Google Chrome does it for you, so they won't open a site if their certification is from a different site. So that's, yeah. Email attachments, email and their attachments. What type of email you should open, what type of email you should block or not open. If they are in spam, just delete it. Don't open the emails. And even if you are opening an email, just don't click on links unnecessarily. Then operating system. Keep your operating system up to date, your virus antivirus also up to date. Firewall, personal firewall is always enabled by your Windows, so there's no problem with that. If you have disabled it, then enable it. Lock saver screen. If you have set up a saver screen, then always have a instead of doing uh, just closing the lid or just keeping the monitor idle and letting it go to saver screen, make it so that just make a habit that you press wl sorry, windows and l. So that's to lock your computer. So it will, every time it will ask for your password. So this is an need. What are the needs for it? The model and architecture. This is a CIA principle: confidentiality, integrity, and availability. Confidentiality will deal with your authentication and authorization. Integrity will deal with whether your data uh, has been tampered or not. It will also follow the asset principles. Integrity will or usually depends on the data, right? The data that you are performing. Asset is a principle of database. So asset is atomicity, consistency, integrity, and durability. And integrity usually refers to that I have sent some data and someone changed that data in the middle while it was transmitting to something else. Say I have sent hi and they changed, someone in the middle attacked it and changed it to bye. Then the person that ultimately receives the message will receive bye, right? Or they will receive some encoded data, and they, when they will try to decrypt it using some other key, their own personal key, sorry, then what will happen, they will get some garbage data. That means the data was tampered during the transmission. So they will ask me to again retransmit it. So the integrity should be there, and this is maintained using encryption. Then you have availability, or this integrity is mentioned, sorry, it's ensured using encryption decryption techniques, cryptography. Then you have availability, that your service should be available all the time. If I have a Google service and like Drive, Meet.Google, everything is the meeting, Google Meets are always available, right? You can just open meet.google.com and it will always be there. It's not down or anything, right? For if you take the example of those government sites, you will see that CBSE side. Let's take the example of CBSE. During results, now the board results will be coming out, I think. During this result time, the server will crash. Why? Because they're not able to handle that load. They're not no, properly. They have not set up their proper load balancers. They have not optimized their source code for or anything. So what will happen? The service will go down, and the availability is gone. So the service is not available right now. So the students will have to come back later on. Non-reputation, that is reputation, or if you are what do you say? If you are not able to live up to your contract. See, I talked about SSL certificates, right, in the previous. So if you have provided an SSL certificate and you're claiming that this service is secure, I have encrypted it, and then your certificate expires, or even if, though you were using SSL, you were storing the password in plain text. See, when your data is transmitting, secure socket layer, it's using the SSL or TSL, transport socket layer, security layer. Then your data is encrypted. Once it reaches the server, it will be decrypted. So if your username is ABC and your password is ABC, it is traveling over the internet in the form of 1239778, something like this, encrypted format. And once it reaches the server, it will be decrypted to again ABC ABC. Now it's your duty to take that information, to take that password and encrypt it, and then store it into your whatever database, right? But if you're not able to do that, and your data is leaked, then you were not you didn't deliver on your contract, right? You promised me that you will keep my data safe, but you didn't. So that's non-reputation. That is, you're not, uh, or even if your intention is not to fulfill their obligation to a contract, you're not abiding by that, then that's non-reputation. Need of information security, about security models. Just go over these. uh, you have iPhone application development. So what does iPhone or Swift, when you are coding in Swift, what things you should consider? Sensitive data and protected at rest. What is at rest? When it's at your, when the data is not moving, so it's on your storage. So you should protect it, right? You should encrypt the data. Buffer overflow, and other C programming issue. What is this? When you have in C programs, you can overload the buffer, and that can lead to security vulnerabilities, because when you are overloading it, you are going out of scope, and you are trying to access some memory which some other program is using, and that way you can run your suspicious code as well. So this is also an issue with C programs. Secure communication to servers, again SSL. Patching your application. If there's a vulnerability, fix it and release it as quickly as possible. Fix it, test it, then release it. Platform itself. Obviously, the platform should have some authentication and authorization setups in place. Application development strategy. Again, the same thing. Not much change. Model and architecture. This is a security architecture. Basically, it follows the principle that at every step you have to make sure that you implement security. Every part of the SDLC process, software development lifecycle, you should be following the proper security procedures at every stage. So during the requirement phase, gather the requirement, set up a security procedure in that place. Then in the designing phase, again set up the security procedure and make the design accordingly. Then in the implementation phase as well, in the coding phase, in the testing phase, in the maintenance phase, in the deployment phase, in every phase you should be implementing security. You should be revising security or implementing it, whatever. Okay, so this is just your how you to aware people the need. Then you have some legal and ethical issues. You can read the IT Act as well. This has been recently updated as well, so there are some things that have been changed. And just focus on this portion of offenses. Appellant, you can, or yeah, these the electric governance. What is that? What records are recognized? Digital signatures. Uh, Attribution, you can go over that, or you can just start from. These are the your certifying authorities, CA. These will be allocating you SSLs. So you can go over this portion also. Then you have electronic signatures, e-certificates. Then you have subs. You can skip this subscribers. This is penalties, and then you can go to offenses. And yeah, I think that's it. That much is enough. So this will also focus on that portion only. So 10 postulates about confidentiality in the business world. First says that the dynamic security mechanism is required to prevent losses. Loss is equal to cost. It will help to achieve objectives. That is the continued smooth operation of business while ensuring security of both tangible and intangible elements of business. Tangible is the portion that you can touch. Intangible is like softwares. Then you have security of employees, security of information, information system. Then you have to also manage the risk. The formula is intention plus ability plus opportunity. Just go over these postulates and let me know if I have any particular doubt. And even if you just go over the IT Act, you will have a good understanding of what these terms mean. So these are some acts that are present. The Family Leave Act, Pregnancy Discrimination Act, Health Insurance. Basically, the theoretical portion, the human resource portion you are reading right now. Okay. Importance of ethics. This is from okay. Just go over this unit. This is a totally theoretical portion. You just have to understand the various acts. You have to understand the postulates, what to follow, what are the regulatory bodies that are doing their jobs, or you can just go over the IT Act as well. This will also give you a good idea about Indian law of for cyber security for uh, cyber things. Okay, and I think you only have one class today, right? 1 p.m. So just go over the block one. Go over block one, and in the next session tomorrow, we can discuss your doubts, or we can start with the next session. Okay. Yes, Manjeet.
Okay, I have one question not regarding with the content that you have shared.
Mhm.
Actually, I have filled the term and exam as well, and there was option for the theoretical section and the practical section. So practical section will also cover in classes, or it will cover.
Yeah, practical classes will also be covered. I think
Mm-hmm.
Anup Girdhar sir, or tomorrow you will have a practical session. Okay.
Okay, okay. One more doubt is there. In this counseling schedule, we missed one subject, MSc 24, I guess.
MSC 24.
Yeah,
Okay.
that is not scheduled.
You can email that
Mm-hmm.
to us, and or you can just directly call. I think. Can you give me the code? What your which code was?
MSE 024. I can
M
type it in chat.
M MSEI.
E. No, it's only
Only
E.
MSE
Yeah.
024. Okay. MSE 024 is not there. Okay, I will raise this with my superiors and get back to you. Okay.
So all practical sessions will be included. There's no physical visiting required
No,
to the
no, no,
center, right?
no, no. Physical is not required.
Okay, thank you.
Welcome. All right, guys. And I hope you have all provided your uh, enrollment
Let me
number.
provide again. I haven't provided again the
Yeah.
details of.
Everyone else, please provide your uh, enrollment number and name in the chat box for attendance. So, okay, for see the project in your project, I think for MSCIS, there's not much coding required. You have to just prepare your thesis, I think, on a particular topic. I am not from MSCIS background, so I'm not sure I can help you with the project. Tomorrow there will be Anup Giridhar sir will be in the class. You can ask him for the project details, okay? But I think it will. It's there's no coding involved, as far as I can tell.
Okay.
Okay.
So, sir, when we need to submit the assignments
I think your last date is this month's end, na? 30th May is your last date. So
to
just
submit the assignment?
as if your study center is 07162,
Yes, yes.
then assignment submission link is open. You can uh, visit merit.ac.in. You will see the assignment submission link there for TE June 2025. Okay, in the Google
Okay.
form you can submit the.
Actually, I don't know, sir, what to submit in the assignment.
In assignment, you will have to submit your theoretical portion as well as the whatever is in this semester. Your course code, whatever you have to submit. Like for example, this MSCI 021. So we'll have a theoretical portion as well as a practical portion. For theoretical portion, you have to write it on a A4 sheet, ruled A4 sheet. Read your answer, write your answers on that, and then you can create a PDF, scan the files, create a PDF file, then submit it to the uh, submission link which is available on merit.ac.in. And for practical, you can type them on your computer using Word.
So the practical will be after this examination, which is conducted in the month
Yeah,
of June.
yeah. Examination will happen in June, July 15th up to 15th. I think there's examination. Theoretical examination will happen in June and July. After that, after like July 20th or 20th, your practical exams will start. And for practical exams, you have to visit your study center. So if your study
Okay.
center is Merit 07162, then you have to come to Merit. Okay. And the same
Okay.
the schedules will be emailed to you as well as you can check them on the website in merit.ac.in. You can check for the examination links. The practical link will be updated. There will be new beside it, and you can get your schedule from there.
Okay.
Okay.
Yes. Thank you.
Welcome.
Okay, oh, one doubt is here. I guess assignment last date was 30 April. I already submitted through the Google
Uh-huh.
form portal.
Yeah, that's good.
I
That's good.
yeah. I'm not sure if it is extended. You can check, Rafi, on the portal
Yeah,
if it is extended.
it was extended on 30th April. It
May.
has been
Okay.
yeah, it's extended to 30th May. So any of you who have not submitted their assignment, you can do so. It's important. Another thing is assignment is important because otherwise you won't be able to give exam, right?
Okay.
Or your
And so
marks will show
who
incomplete.
will be the contact person? Can we have any phone number or email ID? If we have
You
any issue, we can call.
you can l- wait. There's a WhatsApp group already. You can go to Merit. There's social media links. Wait, let me provide you with the link. Okay, here you will find. I think MSCIS group is there. WhatsApp. Okay, and you can contact the admin of that group easily. Okay.
Okay.